my name is Scott Simpson, and today I'll be talking about atomic numbers, mass numbers, and isotopes, and what these guys are. Typically, when you look at the periodic table of elements, what you'll see is something like this, a box containing each element, where there are usually two numbers listed in the box along with the chemical symbol. So why is this important? Well, it's important to know how many protons, neutrons, and electrons each atom contains, and what isotope you're actually looking at. So isotopes differ by atomic mass, and depending on what isotope you're looking at, you can get different chemical effects. So, like I previously stated, oftentimes when you look at the periodic table, you'll see something along this fashion, where what we have here is the atomic symbol stating what element it is. Here we have the atomic number, which I'll get into in a little bit. And down here we have the mass number. And on the periodic table, this mass number is determined by a weighted average of the different isotopes of these elements, which I've already made a previous YouTube video on, which you can check out if you're interested in how to do that. But this is not the only way isotopes and atoms are represented. Oftentimes, you'll see them in such a fashion as this, where you have C12, C6, where it's very similar, except in this case, this is where the mass number is. This is where you have your atomic number and your chemical symbol. So, how do you determine how many protons, neutrons, and electrons are contained in this? Well, you just have to know a couple of little secrets. So if we're looking at the atomic number, this is equivalent to the number of protons of whatever atom you're looking at. The mass number is equal to the number of protons plus the number of neutrons. And you can get the number of electrons out by whatever charge is indicated here. So total charge is equal to the number of protons minus number of electrons. In this case, we have 0. So let's go through and determine each one of these for carbon-12. So the number of protons that carbon-12 has, if we look at the atomic number, it's just 6. Number of neutrons. In this case, we have to take our mass number and we have to subtract off the number of protons. So just applying basic algebra, mass number minus number of protons will get us the number of neutrons. So by doing this, 12 minus 6, so we end up with 6 neutrons. In the case of the total charge, our total charge is 0. If it were different, it would be indicated here by either like a +1 or a -1. Since there's nothing there, it's 0. So the number of electrons is actually equal to the number of protons. All right, that's fine. But what about something a little more complicated? Let's say we're looking at an isotope of cobalt. And I'll be explaining what an isotope is in just a moment. So let's look at this guy here. 27, and what did I write down as mass number? 59. So let's determine the number of protons, number of neutrons, number of electrons. So it's easy in the case of protons. We know for our system, we just have to look at the number of, or the atomic number that we have. So in this case, it's just 27 protons. For the number of neutrons, we have to take our mass number and we have to subtract off our atomic number. So we end up having 32 neutrons. In the case of the number of electrons, we have to take our atomic number and subtract off the number, or the charge here. So in this case, we're subtracting +3. We end up with 24 electrons. If we had something where we had a -3, we'd have to do 27 minus -3, which end up being a positive, so 27 plus 3 to get to 30. But in this case, since it's a positive number, you don't have to worry about that. So we have determined the number of protons, neutrons, and electrons for cobalt. Now let's talk a little bit about isotopes. So, isotopes. And isotopes are atoms that have the same atomic number, but differ in mass number. So an example of this, you have carbon-12, and you have carbon-14. Those are isotopes of one another. They have the same atomic number, which is 6, but they differ in their mass number. So they differ in the number of neutrons that they contain. So let's look at an example. What I'm going to do is I'm going to write down the table, and it's going to list 4 different atoms. So we're going to have our atom number. So we're going to call it, if we're looking at a bunch of atoms, like atom X, atom Y, atom Z, we don't know the chemical symbol for each one of these guys. Then we have the number of protons. And we have the mass number. 3, 8, 3, 9, 4, 2, 4, 1. And we want to know which atoms are isotopes of one another. Well, if we're looking at, remember, isotopes have the same number, atomic numbers, they have the same number of protons. The only 2 that have the same number of protons are 2 and 4. So those 2 are isotopes of one another. Lots of times people will incorrectly go by the mass number, in which case they would think 1 and 3 would be isotopes. This is not correct. Isotopes have different mass numbers, but the same number of protons or the same atomic number. So, atoms 2 and 4 are isotopes. And with this quick little lecture, I hope you've learned what all these atomic symbols and things mean, and hopefully how to differ between atoms that are isotopes and ones that are not isotopes. Remember, isotopes are atoms that have the same atomic number, and that's all you really need to know and need to compare. With that, I thank you. If you have any questions or comments, please leave them below. Thanks for watching.